Hi friends, this is Sarvajan here. Welcome to my networking channel. Hope all are doing good. And today the topic I'm going to discuss how to troubleshoot MPLS. So before understanding that, I'm going to give a quick overview how MPLS exactly works. So this is an architecture where I connected PE1, PN, PE2. So all these three routers are collectively called as the MPLS backbone routers, right? So this is at the provider end, and this CE1 and CE2 are at the customer edge router, which is always placed at the customer end. So you have to enable the communication from CE1 all the way to CE2 for the MPLS to work. And what are the basic configuration and how it exactly work MPLS. So the packet is routed from CE1 to PE1, and PE1 will push a label. It will push the label, we'll call it as a label imposition, and then the label packet will send to this provider core router, in which it will do a label swap from label 17 to label 16 say, and then again this label packet will send to the provider edge router at the receiving end, and at the receiving end it will just pop the label, or it will strip the label, and what is pending is only the packet is left, right? So this unlabeled packet will be again sent from PE to CE2, right, customer edge 2. So CE1 also will send the unlabeled packet, and CE2 also will receive an unlabeled packet. So only this will be having the label mechanism. There is a label push and label swap and the label pop. So for the MPLS to work, right, what are the basic configuration we'll do is, first we'll configure the VRF. So always you have to check the VRF on both the end, PE1 and PE2. So if there is a VRF mismatch also, the MPLS will not work. So VRF is a virtual routing and the forwarding information. So it is just segregating a single routing table into a multiple smaller virtual routing instance. And each and every routing instance we call it as a virtual routing and the forwarding table, or a VRF table, that is used to maintain the customer traffic and the routing separate, or we can also say it is used to differentiate between several customer routes. So there can be millions and millions of customers in the multi MPLS cloud. So to differentiate different customer, we are using this VRF. And under this VRF, I will be assigning the RD. RD is a route distinguisher, which is a 64-bit value, which is used to distinguish between two customer identical routes. So assume there are two customers, both are using the same prefix, say 192.168.1.0. So how it can lead to overlapping in a normal routing environment, right? But in the MPLS that is not possible. So MPLS we can prevent the overlapping of prefixes, even though several customers can use same prefix. So that is allowed in the MPLS. Why means MPLS always forward the packet based on the label information. So there can be several customers who can use the same prefix, but the label will vary. Each and every label will be different in each and every customer. So by finding the label information, it will forward the packet. So that's the biggest advantage of MPLS. We can prevent the overlapping prefixes, right? So for that we'll use this. And second thing is LDP and IGP. Collectively we have to configure. So IGP, I'm using this OSPF as a routing protocol. So this OSPF routing protocol will trigger this LDP update between the neighboring routers, the MPLS routers. And third thing is MPBGP. So MPBGP is nothing but whenever this PE1 advertise the label packet to P, it always advertise with the RD value. So it is nothing but a combination of RD and prefix, what we call it as a VPN V4 route. So for advertising the VPN V4 route between this PE1 and PE2, we are using a protocol called MPBGP. So this is a third configuration. And fourth configuration, we will do a normal IPv4 BGP between the customer edge router and the provider edge router on both transmitting and the receiving end. So these are the basic configuration for the MPLS to work and for enabling the communication from customer edge 1 to all the way to customer edge 2. So these are the configuration we need to do. So today what is happening in this particular architecture, this prefix 5.5 is prefix not getting advertised in 1.1, and 1.1 prefix is not getting advertised in this 5.5. So we need to fix the issue why it is not getting advertised. Let us come troubleshoot together. So now let us go to the individual configuration. Let us go to PE1. So what is the first thing? Always you have to check the VRF configuration. Show IP VRF. So this we configured the VRF is red and the RD value is 1:1. So let us go to PE2 and we have to check the VRF parameters in this PE2 also. So let us go to PE2, show IP VRF. So here the VRF is different. So that is one of the reason why we are not able to see the prefix value not getting advertised. So assume these both the customers are belong to some same company, some ABC. So both are using should be use the same RD value, right? So that is the way we can differentiate the customers. Since both are belong to the same company ABC, so in this case scenario, both VRF should be the same. So here I created the VRF name as red, and here it is showing some other name, VRF blue. So now we have to remove that and we have to create it properly. How to do that? So let us go to PE2 and let us remove it. So before removing it, I want to show you one thing. So VRF, both the ends we will configure. First we will configure on the configuration mode on all this corresponding interface facing the provider edge router. I'm going to show that show run interface faster than at 0 by 0. So this also will be configuring IP VRF forwarding blue. So in this case of PE1, show run interface faster than at 0 by 0. Right? So this is we have configured VRF forwarding red, and here it is showing VRF forwarding blue. So we need to remove this corresponding thing and we need to make it as VRF red. So go here, no IP VRF blue. So that what it does, immediately it will remove the interfaces. After removing this VRF blue, automatically everything will be removed from this corresponding table. You can see here now, show run faster than run. So there is nothing is there, IP address, no, nothing is there. So we need to activate it again. So how to do? So first let us create the VRF parameter. I'm going to show that now. So that is the purpose I brought this video. First we should know how to create the VRF and how to assign that to the corresponding interface facing the provider edge router. So IP VRF red. Let us make the RD value. RD value given that as 1:1 and route target. So RD is a route distinguisher which is used to distinguish between the customer routes, and route target is used for importing and exporting the customer routes. So I have done both the things, right? VRF I assign RD and RT value. Now I am going to assign to this corresponding interface PE2. This corresponding interface facing the provider edge router. So go to the configuration mode, interface faster than at 0 by 0, IP VRF forwarding thread. After that also you have to assign this IP address. IP address is 192.168.45.1, 55.55.55.0, and let us do the notion. So this is the thing for you to do. So now hopefully you have to see the prefix advertised over here. So now let us see anything is missing. So now everything I have done, right? So now let us check the routing entries. So previously I'm not able to see any prefix. Now let us see whether you are able to see the prefix or not. So still I'm not able to see the prefix. So there is one more thing is pending which I want to show you. So this also I'm not able to see the prefix 1.1 prefix. CE1 prefix is not getting advertised in the CE2 routing table. So what might be the issue? So let us check the routing table, BGP routing table on the provider edge router also. How to check it? Go to PE1, let us compare it. Show run. So BGP configuration will configure like this, router BGP 234. So keep it in mind, this address family we are configuring for configuring the MP BGP between the PE1 and PE2. That's the first configuration. And the second configuration is for configuring between these two ends, right? That is between these PE1 and CE1. So this is a configuration 12.1, and we can remove this, I think, no override. So go to the configuration mode, router BGP 234, address family IPv4 VRF. So this override is not required. If both are in the same autonomous system, we'll use this. So this is not required. So now let us see. This is the thing configuration, basic configuration we'll do. So now let us check on this corresponding PE2 to CE2. So here you are able to see, right? I have configured everything, VPN v4, everything is fine. But there is no configuration under IPv4 VRF red. This is the configuration we need to do. So this is for IPv4 VRF red. I need to configure this as a neighbor. Then only it will come up. So now let us configure. How to configure is go to the configuration mode. So router BGP 234. This is for establishing the BGP neighbor with the customer. I have to configure this address family IPv4 VRF. So always you have to specify with the VRF name. There may be multiples of customers, right? Assume there is CE3 and CE4. They may be having some other VRF value. So that is the way we can segregate the customer, right? That is the purpose. So now I have to assign the VRF name. VRF name is red. So then let us configure the neighbor. Neighbor is 45.2, 192.168.45.2, and the remote AS is this value 5, and the network is 192.168.45, sorry, 45.0. Mask is 255.55.55.0, right? So we are done with the configuration. So now let us see the prefixes. So now let us see the show IP routing entries. So now also what is happening? Only I'm not able to see the remote entry. 5.5 not able to see. So let us go here to CE2 and let us check it out again. Show IP BGP all summary and let us do show IP router. So now I'm able to see the entry, right? So in this corresponding table, I'm able to see this entry. Let us see from CE1 end also. See, yeah, that's cool. So now we are able to see the entry. CE1, I'm able to see the corresponding prefix value, and CE2, and I'm able to see the corresponding entry 1.1.1. So what is the issue is VRF. So the VRF value is different. Here we configured as a red, and here we have configured as a blue. So that is the reason the prefixes are not getting advertised. So after changing the VRF value over here, and after reassigning the value interface here, this VRF, so IP VRF forwarding red without assign. After that, again, I changed this parameter VRF, that BGP table, right? IPv4 BGP table. I have changed the remote neighbor again. So then the prefixes are getting advertised. So this is the basic thing we have to see always. So now let us do the trace. Trace 1.1.1 source loopback. So C2 is 5.5.5. So 5.5.5 and the source is loopback 0. Yeah, I'm able to do the trace from CE1 all the way to CE2. So let us do from CE2. Trace is 1.1.1, that is CE1 loopback address, source loopback 0. So now it is working fine. So now we are able to understanding, right? So this is the main thing purpose is, so you should know what is a VRF and also how to configure it and how to activate on the interface. In case the VRF is different also, what happens? The neighbor relationship will not get established. So that is the reason you are not seeing this corresponding prefix in the CE1 BGP rate routing table, and this 1.1 prefix you are not able to see in the CE2 routing table. So you are able to see now VRF, RD and RT. And for LTP and IGP configuration, I already told. Let us check it out again. PE1. So what is the command to check is show MPLS interfaces. So these are the basic commands. You always keep it in mind. Show MPLS. LDP neighbor is for checking the neighbor relation. LDP neighbor relationship is established. So we'll check from P also. Show MPLS LDP neighbor. So these are the things you have to check, right? And the another key point you have to understand is you have to always establish a VPN v4 between this PE1 and PE2, and this is the IPv4 BGP. That is the only difference. This is an MP BGP for advertising the VPN v4 route, and the communication between CE2 and PE2 and CE1 and PE1 always will be IPv4 BGP. So that is the reason I'm viewing this with the command show IP BGP all summary. So here I'll be doing show IP BGP all summary, but in case of provider edge router, I'll be using different command. That is show BGP VPN v4 unicast all summary. So this is a command for checking the VPN v4 route. So the VPN v4 is 4.4.4. You are able to see, right, that interface coming here 4.4.4. And here also how to check show BGP VPN v4 unicast all summary. So let us go here all summary. And you are able to see, right? So if you want to do, you can check the ping also 2.ping 2.2.2. So I'm able to reach the ping also from P1, PE2. So this is how you can go and troubleshoot the issue. The main thing is always understand the usage of all these show commands. So that will be easy for you to troubleshoot in a complex networking environment, especially in this MPLS. So there are several configuration, right? So once you understand this usage of show commands, you can easily troubleshoot and debug. So I hope you enjoy this video. Thanks for watching. Please subscribe for more videos. Thanks and have a wonderful day. Thank you.